For decades, air conditioners equipped with P-traps like those depicted here have been causing building owners excessive building operating cost and indoor air contamination. The most commonly used condensate drain systems include P-traps like these. They use trapped water to form a drain seal and allow for condensate drainage. Although simple in concept, P-traps exhibit many failure modes that prevent reliable condensate drainage and expose surrounding areas to water damage. The cost to the building owner in terms of continual maintenance, damage to the air conditioner, damage to the building contents, and health issues are expensive and preventable. I'm Paul Trent, President of Trent Technologies, an engineering research and development company dedicated to providing successful removal of condensate from air conditioning units, a provision essential to sustainable green buildings. You are about to learn why the use of condensate P-traps on air conditioners are unacceptable and introduce to an alternative that works, the CostGard Condensate Drain Seal. The P-trap requires water from an unreliable source to form a drain seal, condensate from the cooling coil. The CostGard device uses air produced by the blower or fan to form a seal and eliminates all the problems caused by the failure-prone condensate P-trap water seal. The user stands to save hundreds, perhaps thousands of dollars every year by replacing the condensate P-trap with this device, which has been proven to be both reliable and effective. Now let's move to the Trent Technologies laboratory. Although dozens of P-trap failure modes have been identified, for this demonstration I will show only 3 common, inherent P-trap deficiencies and follow each with a demonstration of how the CostGard Condensate Drain Seal overcomes these problems and makes possible truly sustainable green buildings. I will use this laboratory simulated air handler to show how the CostGard Condensate Drain Seal works and how its performance compares with that of the condensate P-trap. The simulator is equipped with transparent panels to show what actually occurs inside the air handler of an air conditioning system, events that are not readily visible during system operation. Just as in a real air conditioner, air is drawn through the filter, the cooling coil, across the drain pan and into the blower. For this demonstration, the blower airflow is set to create a partial vacuum in the drain pan compartment, which is typical of air conditioners. A condensate pump, shown in the inset, is used to simulate condensate flow. The first demonstration shows the effect of operating a system with an empty trap. During startup for summer cooling and during winter operation, the empty trap has no seal and acts like a missing trap, allowing air ingestion. If present, toxic or noxic air near the drain outlet will be spread into the building. This ingestion of air also causes condensate to stand in the pan and leads to condensate blowing inside the air conditioner. The CostGard Condensate Drain Seal prevents the ingestion of outside air by taking a small quantity of air from the positive pressure side of the blower. A portion of this air is discharged to the condensate drain pipe to ensure that outside air and pollutants are not drawn into the system. The remainder of the air is directed through the mitered elbows into the air conditioning unit. The air pressure loss in these elbows ensures that the air velocity entering the condensate drain pan is too low to allow condensate to stand in the pan and cause condensate blowing. Fresh air forms the seal during all operating conditions. See how condensate flows freely from the drain pan. One of the most common problems with condensate traps is that they support the growth of algae, catch debris, and become blocked, causing drain pan overflow. This happens frequently, often less than 6 months after P-trap installation or cleaning. The CostGard Condensate Drain Seal inherently guards against such blockage. This special CostGard device, equipped with clear plastic elbows, shows why. Here, soggy oatmeal is used to simulate the slime that often clogs drain lines and traps. Note the self-cleaning action produced by the air entering the device and the rapid passage of the debris. Condensate traps exposed to freezing temperatures will block the flow of condensate, causing drain pan overflow. When condensate freezes, the trap is frequently ruptured, as depicted here. Because it cannot retain condensate, there is no seal and acts like an empty or missing trap. Observe that water leaks from the trap and allows air ingestion and condensate blowing during the cooling operation. The CostGard Condensate Drain Seal retains no condensate. Once condensate flow ceases, the warmer air that forms the drain seal quickly evaporates any water that may be held in place by surface tension. This website contains more information about how and why condensate P-trap failures preclude any hope for sustainable green buildings. It also explains how and why the Trent CostGard condensate drain seal is essential to sustainable green buildings. Tens of thousands are in operation and not one has ever failed. A 23-minute CD PowerPoint presentation which enumerates still more P-trap deficiencies and shows how the CostGard condensate drain seal eliminates them is available upon request. Also, please feel free to contact us by email at info@trenttech.com or by phone at 903-509-4843 to discuss your application.